A very good evening, madam. My name is Ming Hong, matrix number A22A1162. For today, I would like to start our group presentation for the course AFT 2103, Business Statistics. We are from Group 1, Lecture 3, Tutorial 2. Our group form of some 5 members, which is Ling Zong, matrix number A22A1163, Chen Kaisen, matrix number A22A1135, Vincent Le Jiayong, matrix number A22A 1278, Fong Wei, matrix number A22A0101, Tan Ming Hong, matrix number A22A1162. Well, for the data description, there are totally 6 variables. While the measurement for the numerical for the variable, which is liter per 100 kPl, cylinder, horsepower, weight. While the measurement for the brand is categorical. A software for the purpose of testing modern statistical analyze software, which such as SPSS will help us to analyze the data set that we have chosen. Well, we are given a data set for vehicle fuel consumption per kilometer per 100 kilometer with 392 observation. Well, we decided to choose 150 out of 392 randomly by using the lowest matrix number of our members, which is funky way matrix number A22A0101. Our data set is secondary data, which is previously gathered from the primary resources that made available to researchers to use in their study. Well, there are two type of variable, which is quantitative and qualitative variable. Well, in our assignment, we choose quantitative variable, which is well, the quantitative variable is a numerical and it can be measured. Thank you.
Good morning, doctor. My name is Vincent and my number this is A22A1278. Today, I will present a sampling data and record categorical data. Samples are a less extensive group of individuals drawn from a population for the purpose of obtaining information about that population. However, sampling involves picking a number of people or things for a research to represent a target community. Probability-based sampling assign random number to data point to ensure no association between them. Probability sampling methods include random, systematic, stratified, clustered, and multi-thread. Our observation to reaches fuel consumption per 100 km, we chose 151 data from 392 data. This is because the last two digits of number of our group member matrix number as our sample size of this observation which is 1. In table 1 is random 150 out of 392 liter per 100 vehicle fuel consumption per 100 kilometer. And in table 2 is random 150 out of 392 vehicle fuel consumption per 100 kilometer by travel distance in kilometer per liter. In table 3 is random 150 out of 392 engine cylinder for each vehicle. And in table 4 is random 150 out of 392 horsepower for each vehicle. In table 5 is random 150 out of 392 weight from each vehicle per 1000 kg. And table 6 is record random 150 out of 392 brand of car. And for the last table is record random 150 out of 392 cylinder of car.
Hi, my name is Chen Kaishen. My metric number is A22A1135. Now I'll present about the measure of central tendency, mean, median, and mode. In this part, we calculate manually and using ungroup formula. The first one is liter per 100. Mean of liter per 100, we got the answer is 6.3814. Median of liter per 100 is 6.25. Mode of liter per 100 is 7.69. And the second is KPL. Mean of KPL, we got the answer is 16.4087. Median of KPL is 16. And mode of KPL is 13. Next, I will present about the measures of position quartile. In this part, we also calculate manually based on the dataset and using a group formula. In the end, we success got the answer. The first one is liter per 100. Lower quartile of liter per 100 is 6.3814, and the upper quartile of liter per 100 is 6.25. And the second is KPL. Lower quartile of KPL is 14, and the upper quartile of KPL is 18.275.
Hi doctor, my name is Jing, number matrix A22A1163. Today I want to present the measure of variations in our assignments. The first thing in measure of variations is the range. The formula of range is maximum data entry minus minimum data entry. After we calculate manually, the range of variable liter per 100 is 7.85 liter, and the range of variable KPL is 21.7 km per liter. Now I will present the second and third parts in measure operations, that is variance and standard deviations. When it comes to variance and standard deviations, we must calculate the fs and fs squares of each variables. For example, after we calculate manually, the fs of variable liter per 100 is 957.11, and the fs squared of variable liter per 100 is 6375.11. After this, we put in the answer we found into sample variance formula, and then we get the answers of sample variance, that is 1.801 km per liters. For the standard deviation, we need to square root the answer that we get in variance. So after square root, we get the answer 1.342 km per liters in variable liter per hundreds. Besides, we use the same method in variable KPL, and then we get the answers 13.943 liters for sample variance in KPL, and also 3.734 kilometer per liters in sample standard deviations for variable KPL. Okay, now I will continue to present the graphical representations parts in our assignments. We use two types of graph in these parts. The first type of graph is frequency polygons. The second type is bar charts. Both of the graphs use midpoint for the x-axis and frequencies in the y-axis. Now I will explain the first graph, that is frequency polygons for the variable liter per hundreds. In this graph, it shows that the frequency polygons that start with the midpoint is 3.75 with a frequency of 7, and the graph ends with the midpoints 10.615 ends with a frequency of 1 for the liter per hundreds variables. Next, for the bar chart is used for the variables KPLs. In this graph, it shows that the charts that start with the midpoint is 10.36 with a frequency of 7, and the graph ends with the midpoints 29.33 ends with a frequency of 3 in variable KPL.
Next, I will present the numerical descriptive measures. In this part, we have to compare the answer that we got from SPSS software and the answer that we calculated manually. In this slide that we can see got two tables. In these two tables include the answer of measure of central tendency, measure of position, and also measure of variation. In the end, that we can see the answer of SPSS software exactly same like the answer that we calculate manually. Next, we also have to compare the answer that we got from SPSS software and the answer that we calculate manually. In this slide, we also can see got two tables. These two tables include the answer of measure of variation, measure of position, and also measure of central tendency. In this slide, we can see that the answer got from SPSS software exactly same like the answer of that we calculate manually. Next, we have to do a comparison between the graph that we drawing manually and the graph that we create by Excel. In this slide, we can see the graph is frequency polygon for the liter per 100, and we can see these two graphs is exactly same. In this slide, we also have to do a comparison between the graph that we drawing manually and the graph that we create by Excel. In this table, we can see got two graphs is bar chart graph for KPL, and we can see that the graph that we drawing manually actually exactly same like the graph that we create by Excel.
Now I will continue to present the independent sample test in our assignments. We use weight as our variable in this part. There are 5 steps to complete the independent sample test. The first test is identify hypothesis. We need to identify hypothesis alternative and hypothesis nulls. Hypothesis alternative that our group identify is weight mu cylinders 1 not equal to weight mu cylinders 2, and hypothesis nulls that our group identify is weight mu cylinder 1 equals to weight mu cylinder 2. We need to set significance levels, that is alpha equals to 0.05. In step 3, we will apply statistical tests using the software SPSS. By using this software, we can find that the significant level of weight is 0.005. That is lower than the significance that we set before in step 3. So when it comes to step 4, the decision rule is reject HNUNs. And step 5 conclusions, we can conclude that weight new cylinder 1 not equal with weight new cylinders 2. There is a significant means difference of weaker weight between the cylinder 1 and the cylinder 2. Now I will continue to present the analysis of variance, as known as ANOVA in our assignments. In this part, we use the horsepower as our variables, and we do the same 5 steps like in the independence sample test. Step 1, we need to identify hypothesis. That is hypothesis alternative and hypothesis nulls. In hypothesis alternative, we identify that there are different horsepower mil of each brand in our data sets. And in HNUN, we identify that horsepower mil cylinder 1 equals to horsepower mil cylinders 2. When come to step 2, we also need to set the significance levels. They are set in independent sample test, alpha equals to 0.05. And in the step 3, we also apply statistical test to get the answer for the ANOVAs. And then we found that the significance levels of horsepower is zeros. So when it comes to step 4, the decision rule is reject HNUNs. And the step 5 conclusions, mil cylinders 1 not equal to mil cylinders 2. There is a significant means difference of vehicle horsepowers between brands.
Hi, have a good day to our doctor. And my name is FONG, number metric A2280101. So I would like to discuss correlation analysis. So our group chosen the two frequency, which is horsepower and width for each vehicle. So for the present correlation that show 0.752, that show the relationship is strong and positive between the horsepower and width. So, and the other side is the significance that show only 0.00. So that means we can reject the correlation analysis because there was less than 0.05. Next, confidence intervals. So their result by are showing the 95% confidence that the mean score for confidence in the fuel consumption per 100 kilometers for all kind of vehicle will fall between 6.1648 to 6.5979. So our group chosen the wave to compare the cylinder horsepower and retrieve power 100. Based on the table in significant part that show from the upside is 0.000 until the downside only the last is 0.047. The value of significant for the cylinder are difference between the horsepower and return power 100, so that we can conclude the horsepower and return per 100 can affect the weight of each vehicle, and only the cylinder no affect the weight for each vehicle.